Ni hao, wo Xiao Kumar Singh, Vulaiza Designed Analytics LLC. Apologies if I didn't do it right, but what I tried saying in Chinese was, well, my name is Kumar Singh and I'm from Designed Analytics LLC, and welcome to another episode of Throwback Thursdays. Why start in Chinese? Because the Throwback Thursday episode is around China's space laser program, right? If we want to generalize it that way, right? And as I mentioned in a post this afternoon, that the origin of this episode was in a news article. It's a news article from April or May actually, so no, it's not a recent news, but it came across my feed again, and I was going through it. As I was going through it, I kind of got a feeling that this technology goes much beyond space exploration, right? So we are not going there, right? But let's first touch upon that achievement and then try to go through the history of Chinese space program. Why it's so critical, why it's so important. It's because whenever I talk about China, some people say you are really fascinated, fixated. It's because the country started, right, at par with my country, right? And the advancement and the progress is just so baffling. It's a case study, right? Every nation that's developing probably needs to study them, right? That doesn't mean that I agree with everything, right? But in terms of progress, right? And sometimes progress, the speed, the pace of progress comes at the cost of some other things, right? We'll not go there. These episodes are not supposed to be political, right? So what was the achievement that I was reading about, right? So China achieved the world's first, actually in April 2025, it conducted the first successful Earth to Moon laser ranging experiment in broad daylight. What it did is, it basically beamed a laser at the Tiandu-1 satellite, and it received the reflection to precisely measure the distance, right? And this breakthrough, it actually overcame solar interference, right? Because it was in broad daylight. That previously limited actually these kind of measurements to mostly nighttime, right? And hence it paves the way for continuous high precision deep space navigation, but many other continuous high precision applications, right? And obviously autonomy for future Chinese lunar missions, right? And that actually kind of made me look at the history of their program, right? The history of Chinese space program. So let's take a look actually at what the history has been. We will not go very far back, but we will probably start from 1960s. So the first phase, right, the preliminary, the foundations, right, were laid between 1960s to 1970s when China's early interest in lasers showed up in military and defense projects. Like one of the project was Project 640 anti-ballistic missile laser research, and it included a laser development component. However, that was mostly terrestrial, I'll say, directed energy scope kind of laser development, laser technology development, not space optical communication per se. Then 2002-2004, the Bohu laser facility in China began research and development operations in the field. The construction began actually in 2002, right? Operations from 2004 onwards. Take a pause here to understand, right? The first research and development facility in 2002, and look how far they have come, right? This facility is more about high energy directed laser research, right? Possibly for defense or advanced optics, and that's why I mentioned in that post that even though it has been tested as space exploration, there is a way this thing can be, not in its current format, there needs to be enhancements, but one of the most potent weapons, defense weapons, can be developed. Again, we are not going there, we are going to focus on the history, right? So this facility, the Bohu space facility, is more about high energy directed laser research rather than purely space comms, right? Then the early space laser optical communications and ranging projects came into picture. So in 2007, China completed the first dynamic in-flight space laser communication test, right? And that included advances in dual dynamic beam tracking technology, actually, right? Then post 2007, 2010s, during these years, China gradually expanded optical communication research, satellite to ground, inter-satellite or optical links, atmospheric compensation, pointing tracking systems, and optomechanical components. So within a span of, I would say, 5 years, right? It kind of, so you see the facility started in 2002, and by 2010, they had like some really deep tech foundations in place. And around 2014, China began to open up its space optical communication research more to commercial civilian participation, right? And then came the phase of commercial and advanced capabilities, right? So and that's where we get into the most recent timeline. So November 24 to March 2025, right? China's commercial firm Laser Starcom actually launched 2 satellites into LEO and performed a 400 Gbps inter-satellite laser communication crosslink test. Again, this inter-satellite laser communication, this most recent test, I'm not a brightest bulb in the room, but anybody who is into defense equipment, defense deep tech would start kind of connecting the dots to understand what kind of capabilities this could lead to in the future, right? Also in 2024, as part of lunar relay or deep space infrastructure, China, via its deep space exploration, successfully fired a precision laser bounce over lunar distance during daylight, bouncing off a satellite orbiting the moon, right? And then in 2025, a Chinese satellite reportedly used a 2-watt laser from geostationary distances. I think it was the 36,000 kilometer, right? Achieving 1 Gbps downlink to Earth. The future plans, they are ambitious, of course, right? So there is this gravitational wave interometry, I think, if I get it right, which is like a TaiG program. That's what it's called. So that program for space-based gravitational wave detection will rely on some extremely precise laser interferometry across spacecraft. So this is a key feature component, right, of space laser systems, not communications per se again, but precision laser metrology. And also China's near future ambitions for optical networks in space, high throughput satellite constellations, and laser crosslinks, which is like space ground, will likely push more milestones in the next few years. Well, that brings us to the end of our episode. Again, why is it important? It is important to understand that given intense focus and support and an ecosystem, within a very short span of time, a developing country with foundational resources can develop deep tech capabilities. Thanks a lot for watching. I will see you again next week.